Hello, good morning everyone. Today we are going to tackle the phase 3 Dmvpn and nothing else left because we've demonstrated the last time. But today we will do nothing but we will secure, which is an optional feature, but it will encrypt our data so no intruder will see our encrypted data that runs the overlay network. As you know, it is called the Dmvpn or any tunnel because the underlay is our service providers and is over the internet. If I say in another way. And we are going today to secure the Dmvpn phase 3. And as we said, phase 3 is the one we use today. So as you see here, if you say like do show IP route OSPF, we have all the loopbacks have been the topology. Let me show you the topology before the topology we are using is this one. This is the hub, this is the spoke 2, spoke 3, spoke 5 and spoke 6. So this is the underlay. That is the underlay, you know. Like the routers are connected to a router which simulating as an internet. But the tunnel is now we are running from here all the way to there, from here all the way to, so the Dmvpn cloud does not know what is going on or doesn't know what's going on. So the tunnel goes over all the way over the internet or over the Dmvpn. That's what we call. So today we are not doing anything else but we tackle. So we are using an Ipsec in our tunnel so we can protect our data. That is the main thing. Okay, so the first thing is like I put a notepad, so I just want to explain on the notepad and then copy and paste, so you will have the feeling. We will see how the data has been encrypted, or if something happens, we're gonna troubleshoot it. Okay, if the tunnel goes down and doesn't come up because of the Ipsec, then that means like something mismatched, so we will be troubleshooting if something happens, but hopefully nothing will happen. So let me walk you through and how to secure Dmvpn phase 3, and phase 3 is the recommended one. So before I do that, if I say the spokes do show IP route, as I said last time we demonstrated, if you see this percentage symbol here, I think I did not tell you the last time, but this simple thing here, the percentage sign, it says we went back to we have not started with securing yet, but we just went back. I'm just going back a little bit and visiting the Dmvpn, because you know in phase 3 we have only the two commands to use. One command do show run interface tunnel 0. One command is here, and it is where is it? It's here, IB redirect. That is one command right there, and that is for the hub. And the spokes, they've got it. Do show run interface tunnel 0. They've got IB shortcuts. That is what promoted this this phase to phase 3. Before it was a phase 2, but these two commands, IB shortcut, promoted to phase 3, and IB redirect and for the hub, and IB shortcut for the spokes, promoted them to phase 3. And note, the Dmvpn, when we are using a phase 3, we will use multi-point as well. The network type will be multi-point. So before in phase 2 it was a broadcast, broadcast, yeah, DR and BDR. We were having a DR and BDR, but now it's a point multi-point. So if you say like do show IP OSPF interface brief, then what we will see here, because this is a loopback, it's running loopback, so loopback is loopback, but in the tunnel we will see here it is a point to multi-point. Okay, so we don't have to forget that. So okay, nonetheless, let us start our securing. Okay, we said crypto ISACAMP and we are using a policy 1, and then crypto ISACAMP policy 1. I bought it 2 times. Okay, that's a policy 10, but policy 1. Okay, we are using crypto ISACAMP policy 1, and then the encryption we are using AES or advanced encryption standard. That's what the AES or AES stands for. Advanced encryption standard. Yeah, don't forget. And hash is that we are using a hash. We are using a hash SHA, because SHA is better than that's what the security people say. Hash SHA is better than the MD5, because some people say like it has not been broken, but some people say like it might. SHA is better anyways. Authentication we are using a pre-shared key, and group we are using a group 2, and the lifetime is the default, which is 24 hours, 86,400, which is 24 hours. Okay, and now we will start our Ipsec, because as you know, the encryption, or when we are using Ipsec is two. It consists of 2. One is phase 1, which is the handshake, and the second one is the real tunnel protection, which is the Ipsec. So we say like, okay, let me go with this one. Crypto ISACAMP, this command is here, is the key, and the key I name it GRE1. That's just a random name, I did it. Okay, I just use it. And the address, we say like every address, because we are using a multi-point, we are using a point to multi-point. We can't specify the IP address of the neighbors, but nonetheless this one is better, 0.0.0. so every network it will advertise. It will be allowed to use the tunnel interface. Okay, crypto Ipsec transform set. I just picked it up this name like my GRE, and then the GRE is ESB, which is encryption security payload. That's what it stands for, ESB. And then when we use ESB, then we are using AES, which is encryption, which is advanced encryption standard, and then ESB ESB encryption standard encryption security payload, and then SHA, which is the one we used, and then HMAG, which is a hash MD5 authentication code. Okay, and then we use a crypto Ipsec profile. So because now we are creating a profile to protect it, and we will apply it to our tunnel. Okay, so now we are creating a crypto Ipsec profile. We are creating a profile, and we name it the profile protected GRE. That's just a random name, as I said before, that I picked it up, so you can write anything you want, but they must match. But you know what I mean. So, but you know what is good for Dmvpn or hub and spoke topology thing? You just create one time, and then you paste all of your routers, so it will work fine. And the security association lifetime, it is a seconds, and it is a default time 24 hours or 86,400. And then we set the transform set under the profile, and the transform set I said earlier GRE, and this is the GRE, my GRE, and this one is my GRE. Okay, and then we simply go to the tunnel, and then we select the tunnel protection, then Ipsec profile. So this profile we said like, this profile should protect our GRE. So we select tunnel protection, and then Ipsec profile, and then the name we name it, protected GRE IP, and then we simply go. Also we've got 2 tunnels here. Okay, let me delete this one. So that is the main point. Okay, so let me copy and paste all our devices. So this is the hub. This one is the spoke 1, spoke 2. This one is spoke 3. This one is spoke 5, and this one is spoke 6. Okay, so if you just go here, so the shutdown, let it just shut down for, so we wanted them to, so I will go here and then I will debug Ipsec, debug crypto Ipsec. I will debug Ipsec and then I will debug crypto ISACAM. So we see what happens when they turn on, when we turn them back on. And shut down, and then 5 shut down, and then 6 shut down. So now everything is down. So if you go to hub and say like show IB OSPF neighbors, there's no neighbor because everything is down. So let's go and say like interface tunnels 0 shut down, and then no shutdown. We turn the hub on. We just want to see what's going on there. No shutdown, and then you see the registration and everything is going. Let me make it now. Let us see what's going on here. Okay, just we turn it on. We turn it back on only on R2. Okay, so R2 is it fully it is loading to, and from okay, it is loading. It is adjacency. The adjacency established OSPF neighbor. Yeah, you see. So now from exchange to full already. So now it's full, and it's a multi-point to multi-point. So you don't expect anything here. Okay, because it should be empty here because it's a point to multi-point. Yeah. When we are using a broadcast, we see here DR or BDR or here, but here we do select do show IP OSPF neighbors. Yeah, because we got this neighbor right here, point to multi-point. Okay, so let me analyze a little bit this debug here. The debug here says, where is the debug? Oh, where is it? Yeah, you see the debug, we turn it on. The debug, we turn it on. Yeah, the two debug, we turn it on. So okay, let me analyze a little bit. Say that the ISACAM is on, the link is down, change it to up. Okay, and then ISACAM received a bucket from 172.16.20.2. You know 172.16.20.2 is spoke 2. It's right here. This is spoke 2. Right here, because it's it is 2. Okay, it says, and then it says like ISACAM created a peer structure for the peer, and then using port 800. You know, ESB always uses port 500. Okay, new peer created, locking peer struct, all those stuff. And then I mean, look, processing SA, which is security association payload, and then mismatch happened somewhere here, and finally let us see if things became okay. Now it says ISACAM the input message internal inserted successfully and authenticating using the address. So here is it. IKE MMS IKE1 P1 complete. So now receiving a bucket from, this is the hub we are analyzing here, from 172.16.20.2 from port destination port 500 which is okay, 500, and then QM. So that means like everything is established. So let us see, like do show crypto, ISACAM. So to group ISACAM SA. So you see now we have the established. So if you see QM idle, that means like we are 100% good. So now if we trace, for example, if we do trace route, then 2.2, the loopback of R2, and then we source loopback 0, then we should get it. Source. Then now look, you see, now we are getting, because now we are sourcing, we are getting there. You see, tracing 222. Then if we say do ping, then 2.2.2.2.2. You see, so that means it's working perfectly fine. So let us turn this one on as well, and turn this one on, and turn this one on, no shot, and then see the hub. See, all of them, you know, they get, now they are establishing a secure session using the Ipsec that we've done. Look, so now, yeah, so let me say do you all. So if we say show crypto SA, okay, yep. Now you see we've got all the neighbors. We've got we are in the hub. We have got all the neighbors. You see, because the destination is the hub. Okay, but we got 6, we got router 5, spoke 5, spoke 6, spoke 2, and spoke 3. This is the spokes we are talking about. Spoke 2, spoke 3, spoke 5, spoke 6. Okay, let me make, you see, we got spoke 6 right here, spoke 6 right there, spoke 5 right there, and spoke 3 right here. This is spoke 3 right, this one, and spoke 2, which we had it before. Yeah, and spoke 2. So we all set, and they are all working together. Okay, let me do let me go here and just verify one more time. Show crypto Ipsec SA. So the Ipsec SA, you go a little bit here, what it says that the tunnel interface is tunnel 0. The local is this one, because we are on spoke 2, 20.2, 172.16.20.2, and the local identification is this the IP address of spoke 2. Remote identification, the number, the remote is the hub, which is 172.16.11. That's 16.1.1. The message is encrypted. These are 39, and the message decrypted are 49. Okay, drops. Let us check if any drop is right here. Valid is 0, and I'm gonna decompress it is 0 as well. So let me check if I can see any drops right here. No drop is nothing. Okay, and the status is active, which is perfectly fine. Okay, errors, no errors, no errors here, no failed, or that means like packet is decompressed, failed 0. I mean nothing failed because everything was good. So you know, from the Ipsec point of view, everything is good. Adjacency is there, IPOSPF, neighbors, adjacency is there for R3, R2 do show IPOSPF neighbors. Sorry, you don't need to do here. Neighbors is there, R2, spoke 2, spoke 3 neighbors is there, do show IPOSPF neighbors. R5 is there, or spoke 5, the adjacency is there, IPOSPF neighbors is there. So that means like everything is good. And if you see show IP route OSPF, if you see now, if we trace, let me trace this one, yeah, do trace, for example 2.2.2.2 and then source, or let me even just trace like that. First, you know, whether it is phase 3 or whether it is phase 1, or whether phase 1 always it goes point, it's point to point, but phase 2 and phase 3, the first packet to resolve and to have a VIP, you know, they always have to go through the hub, the first packet, yeah, like that. But if we go now, if we do it again to do trace, now it will go straight away to R2, to R2 or spoke 2 straight away. So we said I do show Dmvpn, then we see we have a dynamic with spoke 2, and static with phase 1, and we started with the 2 dynamic with spoke 2, and static with the hub, the connection. Okay, static connection and 2 dynamic. So this one is a dynamically created. So if we go do show IP NHRB, you see 222, you know, via 10.0.0.2, which is the tunnel. Okay, so that's a dynamically created. You say dynamically created, and the MBMA or non-broadcast multi-access, the real IP address, which is the underlay, which is making the connectivity, is just the MBMA. So I hope that's all, and thank you very much for watching. And I would like to see, and I will see you maybe another video. I mean, so that's basically about it. To, you know, to secure our Dmvpn. Okay, thank you guys, have a good morning.